Good morning. Today we are going to be working on lesson 1.5, problem solving with applying the greatest common factor. So here's an example of they have 18 baseball trophies and 24 soccer trophies. And what is the greatest number of trophies that can be on each shelf? So when you see the word greatest in a story problem, most of the time what they're wanting you to find is the greatest common factor. So greatest means GCF. So here's our trophies. We have 18 and 24, and we're trying to find the greatest factor. So I could do I call it the factor rainbow. So 1 times 18 is 18, 2 times 9, 3 times 6. So they all have a partner, and there's no other factors that go into 18 that are whole numbers. Then you do the same thing with 24. Find all the numbers between 1 and 24 that go into 24. And the greatest number that is on both rows is 6. And so they could put 6 on a row. And so if I factor out a 6 from 18, 6 times 3 is 18. So there's going to be 3 rows of baseball trophies. And then if I take out 6 groups, there would be 4 rows of 6 groups of trophies of the soccer trophies. So if I were to actually put them on the shelf, this would be a picture of them. So we would have 3 rows of baseball trophies and 4 rows of soccer trophies. Let's turn to page 30. So here we have 24 onion bagels and 16 plain bagels, and they want to put the greatest number of bagels that she can put in each bag. So greatest, remember when you see greatest, that means GCF. So here's my factor rainbow, 1 and 24, 2 and 12, 3 and 4. All of those add up. Wait, it's 3 and 8. Oops, 3 and 8. And then it's 4 and 6. There was one group I forgot. So it's actually going to be these two. 8 is the greatest factor that goes into 16 and 24. So if I had 8, then I could do onions, and I would put 8 in a row. Let's see. So we would have 8 bagels in each bag, so we'd have 3 bags of onion. So we would have 3 rows of this. And there's 8 in each row, 1, 2, 3, 4, 5, 6, 7, 8. So 3 rows, and there's 8 onions, bagels in each bag. And then the plain bagels, there's going to be 8 in each bag, and there's going to be 2 rows of these. 1, 2, 3, 4, 5, 6, 7, 8. And there'll be a second bag. Second row. So 2 bags of plain bagels and 3 bags of onion bagels, and each bag has 8 in it. Let's go to page 31. Toby is producing 21 baseball cards and 12 football cards, and they're putting them in packets. What's the greatest number that he can put in each packet? So looking at our numbers of 21 and 12, 21 only has 1 and 21 and 3 and 7. Not very many factors on 21. 12 has a few more factors. Looking at the top row and the bottom row, 3 is the greatest number. So they're going to put the baseball and the football cards in groups of 3, and there's going to be, let's see, 7 groups. 1, 2, 3, 4, 5, 6, 7 groups. So in each of these are going to have 3 baseball cards in all of these little packets. And then the football cards, they're going to be 3 in each of these, and there's going to be 4 packets of the football cards. The bonus word for this video is greatest, because greatest usually means you're looking for the greatest common factor, the GCF. All right, good luck.